Chapter 6, Sample Problem 7. The single threaded screw of the vise has a mean diameter of 1 inch and has 5 square threads per inch. The coefficient of static friction in the thread is 2/10. A 60-pound pull applied normal to the handle at A as shown in the picture produce a climbing force of 1000 pounds between the jaws of the vise. Determine the frictional moment MB developed at B due to the thrust of the screw against the body of the job with the 60-pound force first, and second, determine the force Q applied normal to the handle at A required to loosen the vise. The formulation for a threaded single square screw at the position of, for example, consider a screw under the force with a screw thread with a T and M. To fasten the screw or tighten, the relation is T equals to M equals to TR tangent alpha plus phi. Phi is the tangent inverse mu s because R has 2 phi and we have a alpha here. This is alpha, the thread angle, and alpha is L on 2 PR. L is the properties of the screw and development per revolution. The development per revolution is calculated tangent inverse development per revolution L. And has 5 square thread per inch, so the development per revolution is 1 on 5 2 pi multiplied to 1 inch. Diameter of 1 inch, the radius is 5/10 inch. Alpha can be calculated and phi mu s is 2/10 . So now consider the problem at At first, we are going to provide a free body diagrams for the jaw. The jaw has this approximate sketch. For example, consider this jaw. A force here, 1000 pounds. A force T here, and a force, for example, here at C. We're making a moment equilibrium. T multiplied to the distance 10 was to 1000 multiplied to pounds. Alpha and theta calculated before. For the screw, consider these free body diagrams to tighten the screw. The screw is in the position first. As we said before, we have a R here with a phi plus alpha, R, T, the opposite to this T, and M, the frictional, and MB. MB is the moment that is in the screw due to frictional effect, and we have applied M here. To tighten it, we applied MT, for example, M tighten it, 60 multiplied to the 8, this distance, MT is pound inch. Now we have this relation. To tighten, we have the relation T R tangent alpha plus phi. But M required to tighten is M minus MB remaining tangent MB equals to the both in frictional moment against tightening, and to loosen against, consider these free body diagrams for the screw. In this direction we have another force. In this case N is this direction and T F is in another direction, in this direction. So the direction of T, for example, is in this direction R with the phi minus alpha. T is applied here, M, and MB also in the opposite direction of applied moment, MB. For the tightened, the relation is MTR tangent inverse alpha phi minus alpha. MB minus M excuse me, the M minus MB, M minus MB. MB calculated before because it is the moment that is in the due to frictional force. Point inch Q M on D point required to loosen the screw. To loosen the screw,